control. In level 2, the hands are off, and it's called partially automated. In level 3, the eyes are off. Like in this case, the driver can engage with other activities like reading book during driving or talking with other passengers. In level 4, the mind is off. It means that driver only available in this situation to control in a urgent situation. And in level 5, we have no driver anymore, and everything will be autonomous. But we should know that these connected vehicles are connected to each other through Internet of Vehicles, or IVY. But what is the benefits of using this IVY? In fact, vehicular network, or IVY, can reduce traffic congestion, reduce pollution, increase road safety, improve accessibility, and reduce stress of drivers. But what is the motivation of my research? As I explained, vehicular network connect cabs to each other and to various infrastructures elements via multiple types of V2X communications and in IOV networks. But we're facing some challenges in this dynamic environment, which is security, privacy, and trust challenges. So we need some solution to address these challenges, and blockchain technology functioning as a distributed ledger can help us to address these challenges and address it. As I explained, blockchain technology as a distributed ledger provides an effective framework that guarantees transparency, security, and decentralization in untrusted environments, which is we're facing untrusted in IOV networks. But generally, blockchain designed for public decentralization network, but customized as a permission distributed ledger, or PDL, to address privacy concern as well. PDLs are scalable and particularly suitable for IOV applications which require low latency and secure data exchanges. IOV applications demand low latency processing for enable real-time decision-making and ensure timely responses to critical events in IOV networks. In fact, consensus mechanisms are a key part of PDLs, and it can lead to data processing and validation delays because the consensus mechanisms has a computation overload to the network, and because of that, we're facing delay by using these consensus mechanisms. So, on the other hand, we know that real-time data exchanges is very important in IOV networks because of safety and efficiency of these networks. So we need to handle these challenges. Usually, in consensus mechanisms, we have web servers, which is considered as a wired consensus networks. But we could consider cabs, and we could use the cab's computation power and capability to extend the capability of web servers. And ETSI proposed a wireless consensus networks, WCN, which we could use this to expand the computation power. However, we need to consider that cab's mobility, interference, and signal loss is a challenges in this area, and it can also impact the reliability of the network. So we should address these challenges as well. For addressing these challenges, we propose a hybrid consensus network, or HCN. In this framework, we consider three different layers. vehicle layer, edge level, and PDL level. In vehicle level, we have different group of vehicles. In edge level, we have different RSU or web server. And in PDL layer, we have different PDL nodes, which could be RSU or parked cab. So in this framework, we consider parked cab as a pseudo stationary bag. And also, by using this framework, we could leveraging cab's computation power as well. DPOT, or delegated proof of trust, is that we need to calculate the trust level of each PDL nodes. And for doing this, we have the group of PDL nodes, and among of this group, we are some nodes that are delegated nodes, and these delegated nodes are trusted one, which could be verifier or leader. But how we calculate the trust score of these nodes? In fact, the communication and computation reliability impact on the trust score of these nodes, and also increasing transmission power and computing on high clock frequency can also affect on trust score. And on the other hand, energy sustainability concern raised by ETSI. So we need method to balance between reliability and energy consumption. And the other way, we consider the privacy preservation, and we try to address privacy as well. For addressing this, we consider autonomous group signature. We use autonomous group signature method. As you can see in the figure, the process of this group signature, privacy preservation, is at first when a new cab wants to join to the network, send a join request to the RSU. And after that, the RSU can verify join request and also verify UGC, which is a unique global certificate. And after this verification, the RSU can assign DLC, which is a dynamic local certificate. And after that, the RSU in a fifth step send the DLC and also group key to the cab. So after all of these procedures, now the cab can do transactions and interact with other cabs and participate as a blockchain node or DPL node in our framework. So in conclusion, we propose a hybrid consensus network or HCN architecture that integrates parked cabs into multi-layer web framework. HCN leverages the computational capabilities of parked cabs while considering ETSI guidelines as well. And our goal is to enhance scalability and performance of the PDLs for IOV applications. And also, our goal is to improve reliability and real-time processing in PDL-based IOV networks while enhancing security and privacy as well. Thank you very much for your attention.
Thank you for your presentation. Here's the time for questions. Do anybody have a question? So I have one question from you. In the DPOT consensus mechanism, I guess some part was some kind of vague. How do you decide about the delegate nodes here?
Well, yeah, actually, as I explained, we calculate the trust score of vehicles, and then we consider delegate nodes. And among all the delegate nodes, one of them is choosing as a leader, and the rest of them as a verifier. And as you can see in a figure, the diameter of the circle shows the trust score level and trust level of each node. For example, the green circle is the most trusted node among all other nodes. And in fact, we're trying to find a solution to expand the computation level of RSU. It's obvious that RSU may be chosen for verifiers and delegated nodes, but we're trying to expand this computation by considering parked cabs as well.
Thank you. So, thank you very much.
Thank you.